All right, this is section 4.4, number 21, and we are going to find concavity and inflection points for this one as well. This one's a little bit sticky with algebra, so it's a good one to do. We have to look at the original problem and notice that with a radical, you have a domain restriction, just like you do when you have fractions. You know that you can't zero out the denominator. Here, our domain, because of the radical, is -3. That's the highest value we can use because then we'd have the square root of 0 all the way to infinity. So we'll have to keep that in mind, that any of our answers that are outside of the domain don't work, and so we don't use them. So we have the f of x. I guess we'll rewrite it first. So let me put rewrite. F of x is equal to x times x plus 3 to the 1/2 power. And then f prime of x, product rule. First, x, derivative of the second, bring the exponent forward 1/2, rewrite the base x plus 3, take 1 off the exponent -1/2, and the derivative of the base is 1. So there's first times root of the second, plus the second factor, x plus 3 to the 1/2, times the derivative of the first. So we want to clean this up before we take the derivative again. And I'm not seeing anything that will cancel. No. So I'm going to notice that I have two terms. This is a term, and this is a term, and it's separated by this plus sign. So I want to take out the greatest common factor, and each of those terms have an x plus 3. And the lowest power of those x plus 3's is to the -1/2 power. So that's what I'm factoring out. So we have f prime of x is equal to, out of the first term, I'm taking x plus 3 to the -1/2, and I will be out of the second term as well. To figure out what I get from doing that, I can rewrite the original equation. And divide by whatever I'm factoring out. And we know when the bases are the same and you're dividing, you subtract the exponents. So for this first term, the x plus 3 to the -1/2 will cancel because they're identical. For the second term, we need to subtract the exponent. So the exponent will be 1/2, the upper exponent, minus -1/2, the lower exponent. So 1/2 plus 1/2 will just be to the 1 power. So we are then going to have f prime of x equals x plus 3 to the -1/2 times 1/2 x plus x plus 3 to the 1 power, which I won't write. And so this is going to be f prime of x is equal to x plus 3 to the 1/2 in the denominator. Here I'll combine like terms, and that's 3/2 x plus 3. And now I will take the derivative again. I'm off the screen a little bit. So f double prime of x is equal to quotient rule. Low, x plus 3 to the 1/2, d high, 3/2, minus high, 3/2 x plus 3, d low, 1/2 x plus 3 to the -1/2, all over low low, x plus 3 to the 1/2 squared. And once again, we have two terms in the numerator. And once again, we have a common factor of x plus 3, and the lowest power of the lowest exponent is -1/2. So we do it again. So I get f double prime of x equals, and I'm pulling out an x plus 3 to the -1/2 power. To figure out what's left, I'm going to rewrite the original in all its messed up ugliness. And divide by the same thing that I'm factoring out. And you end up doing this over and over again in this section and in this chapter. denominator is just x plus 3. So we get f double prime of x is equal to, this guy I'm going to move down, that x plus 3 to the negative 1/2. So I have x plus 3 to the positive 1/2, and there's already an x plus 3 there. And then looking inside my parentheses, here I'm going to subtract the exponents. So I have 1 minus negative 1/2. And so that's going to be 3/2 x plus 3 to the 3/2. And then for the next term, the x plus 3 to the negative 1/2 cancel. And I get minus 3/2 x plus 3 times 1/2. So now we have our second derivative getting cleaned up a little bit. We're going to, that one is bothering me a little bit. Let's see where we're going with this. So these can be combined by adding the exponents. We can distribute the 1/2 into the second parentheses because it doesn't have an exponent on it. We cannot distribute the 3/2 into the first parenthesis because it does have an exponent on it. So f double prime of x is equal to 3/2 times x plus 3 to the 3/2 minus, let's see, 3/4 x. Remember that minus goes through 2 as well. Minus 3/2. Denominator is x plus 3 to the 3/2. Okay, so now we're going to set the numerator equal to 0, set the denominator equal to 0, because both of those, as long as they're part of the domain of the original function that we started with, they are then possible inflection points. And if you set the denominator equal to 0, you're going to have x equals negative 3, and so that is a possible inflection point, and we will be using it. If you set the numerator equal to 0, it doesn't work. So it just, there are no values that you're going to get from that. So our possible inflection point actually is only from x equals negative 3. And so we are going to make a number line, break it at negative 3. And we can't go left of negative 3. And remember our domain is negative 3 to infinity from the original problem. So that's all we can check is negative 3 to infinity with a test point. And so I would suggest using 0 because 0 makes beautiful things happen. So if you do f double prime evaluate at 0, even though this is really quite a mess, all kinds of stuff is going to be gone. And you can do it on your calculator. And the only thing that you care about is if it's positive or negative. If it's positive, then that whole interval is concave up. If it's negative, then the whole interval is concave down. Okay, so I hope that helps. I'll let you take it from there.